Hi guys, today I'm going to be showing you how to do orbital diagrams. They're pretty easy once you get the hang of it, so yeah, let's get started. Okay, so first you need basic knowledge of the sections in the periodic table of the elements. Basically what I'm saying is this section here is S. This is called S, the green part. This section here is called D, the orange. This section is called P, so blue, I guess. That's what I colored it anyway. And then this section over here is called F. Okay, so basically, if we look at it from here, this section is S, including helium, which is over here. This section is D. This section is P. This section. And this section is... oh, just kidding. This section is F. Here you go. All that rectangle. Okay, so before we get started, I want to mention one thing, and that is, these rows are... not that, just kidding. I shaded that out for a reason. Okay, so this is basically row 2, and this is row 3. I guess you already know that. But when you come to section D, this part is 4, so this is 4S, but this is not 4D, it is 3D. And this row over here would be 4D, this would be 5D, and this would be 6D. And the P is same as section S, it follows the normal logical way. And D, I guess like skips a number or something, I don't know. So, yeah, you need to know that first. So, let's get started on the orbital diagram itself. Iron is right here. So this is iron right here. As you can see, it's in one of those irregular rows, so instead of it being 4D, it's actually 3D, so it's in row 3D, because it's in section D over here, and it's row 3 for D, you know what I'm saying? Okay, so, you need to find 3D, right? Section D, row 3, not 4, 3. So it's 3D, and then you need to find how many boxes are, apart from the beginning of the section. So basically 1, 2, 3, 4, 5, 6. So it's 3D6. That would be the electron configuration of iron. And yeah. Okay, so I'm just going to do it on another piece of paper because my paper is kind of small. It doesn't really have that much room. I'm going to zoom in here. So this is iron. And we just found out that the electron configuration is 3D6. Got that? Okay. So now we need to find out how many sections are before 3D6. So basically, we want to... I need to zoom out. Okay. We need to count the sections. So this would be 1S. This is 1S. Just pretend helium like swap places here. Okay. So this is 1S. This is 2S. This over here would be 2P because this is section P and it's in row 2. So 1S, 2S, 2P, 3S, 3P, and then 4S, and then 3D. Okay, so let's just write down those sections. So we don't write this down if you're planning to copy this. Okay. So this is so the sections are 1S, 2S, 2P, 3S, 3P, 4s, and 3d. 3d. Okay, you got that. So now I'm gonna give you even more background knowledge. There's these things called orbitals, and they hold the electrons, and each orbital holds 2 electrons. So basically, over here, okay, so how do I say this? Okay, so hydrogen and helium are a part of section 1s. And since 1s is 2 boxes, it would be 1 orbital. So 2s, since there's 2 boxes, usually like divide by 2, so there would be 1 orbital. 2p, it's 6 boxes wide, so 6 divided by 2 is 3. There would be 3 orbitals over here. 3s, 2 boxes, 2 divided by 2 is 1 orbital. 3p, 6 boxes wide, 6 divided by 6 divided by 2 is 3, so there'd be 3 orbitals. I just got a British accent. Anyway, 4s, so that would be 1 orbital, because there's 2 boxes. And last but not least, D, 3D, the special rows of D's. Okay, so these are 10 boxes wide. Go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are 10 boxes wide. 10 divided by 2 is 5. So there would be 5 orbitals. Okay, so now we know the number of orbitals for each section. Okay, so 1s, which is right here again, 1s is 1 orbital. 2s is also 1 orbital. 2p, which is, remember, 6 boxes wide, that would be 3 orbitals. 3s is 2 boxes wide, so that'd be 1 orbital. 3p is 6 boxes wide, so 6 divided by 2 is 3 orbitals. 4s, 1 orbital. 3d, 5 orbitals. Okay, so it doesn't really matter if it stops midway. You still have to write all the orbitals. You can't just skip out on the last few. Okay, I'll show you that in a little bit anyway. So once you have that figured out, all you have to do is draw lines for the orbitals, okay? So here would be 1s. Here would be 2s. 1, 2, 3. This is for 2p, because there's 3 orbitals. This would be 3s, just kidding, I messed you up. 3s, this would be 3p, 3p, 3, oh, well, mine as well. 2p, 2p, okay. And then this would be 4s, and then 1, 2, 3, 4, 5, oh my god. This would be 3d, 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 3, oh, this is not working. Hold on. Make your blanks smaller, because I ran out of room. Okay, 3, 4, 5. So this would be 3D, 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 3D. I want to go to the IMAX. 3D. Okay. So you see what I did there, because there's 1 blank for 1s because there's 1 orbital. There's 1 blank for 2s because there's 1 orbital. There's 3 blanks for 2p because there's 3 orbitals. And you just keep going like that. And yeah, this is supposed to go here. I don't have any room, and I'm a sucky chemistry teacher. Okay. So once you got that down, this is where the 3d6 comes in handy. Okay, so you know these little arrow things, right? That's the whole purpose of the orbital diagram. So this section is already closed off because since iron is over here, it basically passes 1s. Yeah, so it's basically like, that's like complete, kind of. Okay. So this would be up and down because the section is complete. Okay? So this would also be up and down because that section is also complete. It's already past the section 2S. These sections are also complete because it's already past 2P. And in case you forgot, 2P would be right here because iron is right here, so it already passed that section. 3S is also passed. 3P is passed. 4S is passed. And now the 3D6. You know, the 6, remember this little, the 6, because it's 6 boxes in the D section. 1, 2, 3, 4, 5, 6. 6 boxes, okay? So you don't want to just do an up arrow and then a down arrow because, well, that would technically be wrong, I guess. You basically want to do the rounds. So instead of going up and then down and then up and then down, you have to go up and then you have to go to the other 3D blank and then you have to go up again and you have to do that 6 times. So basically you go up, okay, so 1, 2, 3, 4, 5, so all your up arrows, but you've only done 5 arrows and this says that we need 6 arrows. So therefore we have to go back and we have to make this down arrow. And that would basically be our orbital diagram. The reason why you don't do this right away is because these would technically like be empty, so they're not like filled up. So hold on. Basically, like my chemistry teacher explained to me, is basically it's kind of like a bus. Okay, you have seats over here, seats over here, seats over here. Okay, my bus has 5 seats. Deal with it. It has 5 seats because, you know, 5 blanks, 5 orbitals. Anyway, so say up arrow over here. It wants to sit down, so it sits in this seat. And then the next arrow comes along. It's not gonna sit right beside him. That's creepy. The guy's a creeper. So he decides to sit over here. And then another guy pops up, and he sits over here. Another guy pops up, he's over here. Another guy pops up, he's over here. Okay, so now all the seats are full. But as you can see, there's well, I guess 6 passengers. And so far only the up arrows have taken up the seats. So the down arrow comes along, and it's all like, oh my god, all the seats are preoccupied? Where am I gonna sit? So that's when it has to make a sacrifice and sit next to some random stranger they don't know and be a total creeper. So they decide to sit over here. So that's basically saying, like, if you have another bus, I'm just gonna make a real bus really quick. Okay. That's basically saying, if one person sits here, another person, a random stranger, is not going to sit right beside them because that would be creepy. You see? They have to spread out to the other seats, orbitals, blanks, before they can sit with someone else. Because, you know, this guy's like a total creeper. Okay, anyway. So that's why you don't put an up, down, up, and then you put up, down, if that makes any sense. So basically, this whole arrow diagram right here is the orbital diagram. I hope this helped. I tried my best to explain it. I'm not really good at explaining things. yeah, I hope you guys like my orbital diagram thing. Oh wait, hold on. I was gonna do another example. No! Okay, move on. I only decided to do 2 more examples because I'm being really lazy right now. Okay, so let's start with rubidium. Let's see if you guys got the hang of this. Okay. So let me zoom out of this. Rubidium is right. Rubidium, right here. That took me way longer than it should have. Anyway, okay, rubidium you have right here. Got to find out the section S, obviously, because this whole section is S. Section S, row 5. Okay, so it'd be 5S, 5S, 1. Because this is basically numbered like 1, and this is basically 2, like in the seats of section 5S. If that. Okay, so basically, if you were looking for strontium, this would be 5S2, because this is the second section of 5, this is the second seat, I guess, of 5S, and this would be the first seat of 5S. So rubidium would be, 5S1. You gotta remember that for this problem. Rubidium. Okay, so again, you're just basically gonna find the sections, just like last time. So it's gonna be 1S, 2S, 2P, 3S, 3P, 4S, 3D, not 4D, 3D, 3D, and then 4P, and then 5S. Okay? Does that make sense? You get it? Because because this is 1S, 2S, 2P, 3S, 3P, 4S, 3D, 4P, and 5S, and you just stop when you get to the section that rubidium is in, or the element that you're finding, I guess. We're going to find the orbitals for these sections. So this would be 1 orbital, this would be 3, 1, 3, 1, 5, 3, and 1. Okay. Let me not write so big this time, I guess. Okay, so this 1 blank for 1S, 2S, 3 blanks for 2P, and 3S, and this would be 3P, 4S, 3D. Oh no! Wait, hold on. That didn't happen. 4S, 1, 2, 3, 4, 5. 3D, 1, 2, 3, 4. Oh god, dang it! So close. Okay, 5S. So close. Okay. Anyway. So, like I said, rubidium is all the way here, so it's already past all these sections that we mentioned before. So, this would already be filled up. This would be filled up also, and it just keeps going like that. Okay, so once you got all those filled in sections with the arrows, It's time to actually do the one that makes the difference. Okay, so 5s1, remember? So this is only going to have one up arrow. Just one. So it's only going to be like this. There's no down arrow because it's 5s1. It's not 5s2, or else that would be strontium, or however you pronounce it. So if this was, don't write this down, if this was down, this would be a completely new element, and it'd be 5s2 strontium. But it's not. It's 5s1 rubidium. Therefore, there's only one up arrow because there's only one. So this all connects to the electron configuration. Yeah, so I'm just going to show you guys one more example. Okay, this might screw up a lot of you guys because you guys are going to be like, oh my god, what the heck does this +2 mean? Oh my god, I'm going to die, I'm going to jump off a bridge, I'm going to get hit by a car and ran over, and I'm by a 5-seated bus. It's not that scary, really. It's just adding another step to the orbital diagram. So, finding magnesium. Magnesium is right here. Section S, row 3. Okay, so 3s2. Because it's not 1, it's not sodium, it's magnesium. This would be 3s1. You don't want 3s1, you want 3s2. So 3s2 is magnesium. So let's just write that down. 3s2, it's slanted. 3s2 is magnesium. Okay, so now we know that magnesium is 3s2. So, name the little section things again. So it would be 1s, 2s, 2p, and then 3s, and that's it. That's it because, as you can see here, 1s, 2s, 2p, and then 3s, and then we stop right here because magnesium is right here. And, well, you know, this is kind of like a bookmark, I guess, if you could call it, like a stopping mark, a stop sign. Don't want to get a ticket. Okay, anyway, so this has one orbital, 3 orbitals, and then 1 orbital. So therefore it would be 1, 2, 3, 4, 5, 6. Okay, this would be 1s, 2s, these 3 blanks would be 3p. Just kidding. It's 2p. 2p. Okay, and this would be 3s. So this section's already filled up. This section is already filled up. This is already filled up. And then you come to 3s. And then you look at this. And then you see 2. And then you just draw 2 arrows because it's 2. It's not 1, it's 2. So, yeah. And now, here comes the +2 part. This +2 means that this atom is it doesn't have as many electrons as it needs because it's +2 positive. Okay, so my finger looks really weird and short. Okay, anyway, +2, it's positive. So you basically, okay, so these are basically the electrons, right? So, and it says +2. So initially you're doing -2 from the electrons, which are these. Okay, so it's a +2. You subtract 2 of these arrows. So basically you're just crossing out this whole I shouldn't have erased that. Hold on. I shouldn't have erased that. Hold on. Please stand by. Okay. So basically you just wanna beep. Okay? because it's plus 2, so you're subtracting 2. So basically, it's the same with potassium right here. When you have the arrows, you just subtract 1 because it says plus 1. And then with fluorine, with a negative number like this, you would do plus 1 arrow because it's minus 1, which means it's negatively charged. So you would have to add another electron to unbalance the even positive negative proton electron scale. Yeah, so this would be your complete orbital diagram for magnesium plus 2. So yeah, that's all I'm gonna show you guys today. I hope it somewhat helped you with your orbital diagram problems. I'm not that good of an explainer, so I'm sorry about that. I tried my best, but I made this video because I was reading on how to do orbital diagrams, and I got so confused because in words, it's just really confusing to like understand, but if you like actually see what's going on, then you can like comprehend better. Well, for me, I guess. So yeah, I hope this video helped. Thanks for watching this incredibly long video that shouldn't have been so long. But yeah, enjoy your chemistry orbital diagrams, and I'll see you guys later with possibly another tutorial on homework problems, I guess. I'm in 10th grade, so I don't really know what level your homework problems are, but yeah, thanks for watching. Credits to Mr. Evans for teaching this so easily, and the busting, that really helped. Okay, I've been talking too much. Okay, bye-bye.